So just to go over what we plan to do this week. So we're going to have some very practical sessions today and tomorrow. We're going to be writing and deploying some programs. And then on Thursday, it's the team project day. We may add a little bit of theory before, maybe not spend the whole session on the team project, but we'll see how we go in the next couple of days. But that's the idea for this week. And then today I'm going to give a quick talk about what's happened on Solana over the weekend, and then we will be looking at how to write and deploy programs to Solana, the very practicalities of it. So it's going to be a very practical session today. So let me just check. Bots broke Solana. Yeah, that's the summary of it. Bots broke Solana. What happened, as you can see from the status page on Solana, had a couple of bad days. We had an outage of a few hours. This is the incident report about it. It was about 7-hour outage, and it was down to bots. It's interesting actually that a similar thing really happened to Ethereum around about the same time, in that there was a huge demand for NFTs, and it's interesting to see how Solana and Ethereum reacted in different ways. So I'll just mention Ethereum to start off with, just that on their network, it didn't cause an outage as such, but the gas fees rose to incredible prices, so it was fairly unusable for normal transactions. On Solana, it did actually cause an outage, and the problem was because someone said there was a bot that was there were NFTs being sold, and because these NFTs were being sold sort of first come first serve process rather than it being an auction, something like that, it meant that the bots were set up to sort of just try and buy as many as possible as quickly as possible. So this caused a massive amount of transactions on the network. So you can see here it's like 6 million per second, which is a huge amount. And so obviously that's going to be problematic. That's a lot of traffic to deal with and a lot of data to deal with. As I say, I don't think it was a denial of service. There's no evidence of that. It really was just normal business causing this problem. And what happened with the validators was just that they ran out of memory trying to handle all of these transactions, and then they didn't then have enough memory to deal with the consensus process, the process of voting, and so that caused the network to fail overall. And it's interesting that if you think about the sort of scalability, the scalability trilemma, and how blockchains work in general, you can increase the requirements for a node on your network, such as a validator. You could make the requirements for that much, much higher, in which case perhaps they would cope with more. But then as you do that, you become less decentralized because there are fewer people able to participate. So this is kind of a fundamental problem of blockchains, maybe, or networks, I suppose, trying to deal with this. But they do have some ideas how to get around this. So there are some ideas around network flow. So these are very specific about how controlling network packets. I don't know the details enough myself. There's also the idea that something to do with the stake weighting for the validators, and then that will influence how many transactions they pass on. And then the third idea they have is the idea of some kind of execution priorities. So this is something that is new, I think, and the idea behind it is not to, well, it's slightly different. It's perhaps a little bit more finer grained than the types of things you see on other blockchains, where people are putting up higher fees for inclusion in a block. This is more that you're putting up a fee for access to a particular piece of a particular resource, where that resource is a particular piece of state on the network. Because if you remember with Solana, they have this idea that we can do things in parallel, because we can split out the state and we can control and understand what transactions are referring or trying to change which pieces of state. So the fees could be based on that. So you could effectively, you're not kind of competing, not everybody's competing for the same thing, but for the few people who are competing to change the same piece of state, then they would be competing based on their fees. So that's quite an interesting idea that they've got. If you want details of that, if you have a look at the report from Solana, there's more details. It was interesting as well. Some people did complain about the way this was handled, and saying that there's a kind of a censorship going on because of the way the network was brought back up. But I think this perhaps can be seen just as that they tried to get the network back up, and to do that they tried to exclude certain transactions, but that was just so that they could get the network going again. It wasn't kind of a blanket idea of sort of censorship or whatever. So yeah, so that was the outage. Anyway, hopefully, hopefully we don't get many more of those. All right, so before we go on to some of the details of deployment, just want to talk a little bit more about the accounts model. I've got some links at the end to go into this in more detail if you're interested, but it's something that is perhaps different to what you may have understood before, and it is quite important to get a handle on this, because Solana is very much about accounts and what they and the different kind of roles that different accounts have. So first of all, they can be executable or non-executable, and they have an owner, and then that gives them rights to do modification, and then the accounts can hold bytecode or state, and also funds, as you know. So we've got LAMP ports, which are fractional SOL. So typically the accounts would have these attributes. So a number of LAMP ports they own, who is the owner, whether it is executable or not. So is it a program? Then the data, so this is the state that is going to be stored in the account, and then something about the rent. So I explained before this idea that we rent state on Solana, so this is how we track that. And then there's a graphic there to sort of show you the possibilities of that. Yeah, so I think that's sort of fairly self-explanatory. So some things can be signed, and some things can't. And yes, so then some things can be modified and some things can't, depending upon whether you're the owner, etc. If you don't have enough rent, enough balance of LAMP ports for your rent, then you can be removed by the sea-level runtime. And this is evaluated every epoch. And if you can put up a certain amount up front if you want to. Okay. If you look at particular accounts and their ownership, you can see this kind of thing. So there are some things will be owned by the system program. So this is an example of a particular program that is owned by the system program. They can be owned by a program itself. So there's an example of that, or maybe the BPF loader as well. And yeah, so if you have a look at accounts on the Solana, this is the type of thing that you will see. Okay. One thing, could I don't know if we've had have we posted the Slido link onto chat? That's probably the best place to ask questions if you have them. Okay. Right, so that's just a digression to about accounts. I'll talk now about the architecture of an application. So this diagram explains it nicely. So there will be something on chain, so some program on chain and some accounts that are storing state. Obviously, so that is what we're going to interact with. And then we will interact with that from a client, and that will be done via RPC nodes. So they'll be doing remote procedure calls. And then in addition to that, you may have other components such as decentralized storage. And Tom spoke to you about some of the options you have there with Arweave and IPFS. There's also the task scheduler Kronos, which is a means of getting a program or a piece of code activated at a particular time, similar to a cron job, for example. Or you can have input from outside, such as Oracle, so from Chainlink to provide data as well. So this diagram shows that we have the process that you start off. You can write a program in, well, we're concentrating on Rust, but you could do it in C, C++, anything that the LLVM compiler will be able to, which has a BPF backend for. And then that is compiled and deployed to the Solana network. And then that also involves the setup of accounts. And then the client can then interact with that via RPC calls, via the API. And the client, there can be different types of clients. So it could be that you're calling something from the command line, or you could be doing things via a JavaScript SDK, or whatever. But those will be they will be bundling together or creating transactions, and as a remote procedure call, and then sending those off to the RPC nodes to interact with the program. The programs themselves can be thought of in distinct modules, and you can have these in individual files. In some of the examples we're giving in a moment, we've put these together into one file, but as things become more complex, you can put them in individual files so that it's easier to understand the role that they have. So these are the files that are often used for that. So you will often see that if you're looking at a particular Rust program. We often put those into a single file. But it's a nice way to make it more modular. So you'll see this type of thing if you're looking at some code in a repo, for example. Then the architecture of the repo will vary. So something we won't do this week, we'll come on to next week, is a framework called Anchor, which simplifies the process of writing your code. We're starting off at a sort of more fundamental level because it's important that you get to grips with that and understand that. But the Anchor can save you time and take away a lot of the kind of the boilerplate, or sort of abstract a lot of that away. But we'll do that next week. Anyway, so your cargo project architecture may vary because of that, and also whether you've done this sort of more modular approach or whether you've kept things into one file. But it follows the typical Rust setup that you'd have a source directory for your source files. There will be a target directory, so that's the compilation targets, so that will hold the binaries that the compiler produces. You would have a tests directory to put your unit tests in, and then you have your cargo files. So these will specify the config of your project, and it also automatically generates a particular dependency file for your project. Yeah, just another diagram to show the RPC there. Sort of a little more detail. Yeah, showing how the programs go to the are deployed, and then the clients interact via the API to interact with the programs. Okay. There's a link there to the RPC API. I think we mentioned this a little bit last week when we looked at the doing things via the command line. So you have a little bit of experience with that, but there's more details there via that link. And what it looks like if you look at the actual objects that are sent across to an RPC node, it looks like this this kind of thing, just a typical JSON object. So just sort of showing the configuration of that, and so showing the particular, if you're calling API, if you're doing an API call, what methods you're calling there, and then what parameters you have with them. Yeah, there's the library you interact with is the Web3.js to make that, to simplify that. And again, there's another link there to the methods that you can call if you want to call them directly and find out more details about programs or accounts. Yeah. The program itself, when we're interacting with that, we always interact in a particular way, and there are 3 particular sets of data that we need to supply when we're interacting with a particular function. You can see here what this looks like in terms of the parameters, and so these 3 pieces of information are the program ID. Obviously, you need to know which program you're interacting with, the accounts that are going to be used. So if you remember, the programs themselves are stateless, so we have to tell the program where, we have to supply the state to the program. So that's what when we're providing the accounts. And then the instruction data itself, the actual things that we want the program to do. And it will return this program result, which can be either an OK to say that everything went fine, or it could come back with an error code, in which case the transaction fails. It doesn't return a value here, so you check the you can check the state change by another interaction with the client. So going into that a little more, going to those areas a little more. The program ID, this is the particular the public key of the accounts for the program we're invoking. The accounts themselves, these represent the state that we're providing, and you can think of these. You can think of accounts in different ways. So they could be programs, they may represent state, or they could be wallets. So you've generated a key pair and you created a wallet to hold some SOL. And then in addition, you may be dealing with them in different ways. So you may be they may be there to write. You may be wanting to write to the account, or you may be just wanting to read from the account. And part of the cleverness of Solana and the fact that we can the runtime works so well and is so performant is the fact that we can sort out what calls are going to want to write to particular pieces of state, and we can manage that very well. Yeah, so you can pass multiple accounts when you're passing your details to the program, when the transaction goes to the program, because you may need multiple accounts for that. You may be reading some and writing to some, etc. And of course, the programs could call other programs as well. That could be part of their logic. And then there is the third part, the instruction data. So this is a byte array. So this is saying what we want to be done in this particular transaction. So effectively what function, what parameters we have, all of the details about what the program should actually be doing. And this may be specified, or sorry, encoded in different encoding or decoding schemes, depending on how it is going to be used. And we shall see that when we look at the code itself. Okay, so the general flow that we have in the program is that the arguments, which will have been serialized, are received by the entry point that we have specified for this particular program. And so those arguments, the ones I've just mentioned, the accounts, and we also need signatures as well, and instructions. The entry point specifies which forwards these to the processor module. We shall see this in a second. And then the processor actually does invokes the instructions in the instruction module, and that can then decide, that will use the information that it has to decide which functions it's going to use to process that particular request, transaction or a call. And then that may involve state. We may be reading or writing to accounts. So those will have been passed in as well. And if during this process, if some error occurs, then we will pass back some error code to show that, and then that will cause the program to revert. So that's what it looks like on the program side. The sort of higher level description from the client side, it loads an IDL. So this is just, it needs to know how to interact with the program, but then it connects to the network, puts together the instruction that it needs to send to the network. It submits that as an RPC call, and then once that has completed and come back with either an OK or with an error code, it will then, or it can then read the modified state in the account to see what the result of all of that is. So that's overall the kind of flow that you will see when your program is receiving a transaction from a client. Okay. The typical workflow, the development workflow that you will do will be you will be writing your ROS code and compiling that into a binary file. You would then deploy that .so, that binary file, to a cluster. So that could be a local cluster that you're just running yourself, or it could be a test, one of the test networks, or it could be the main network. Then you will obviously interact with it, maybe running some tests, and then depending upon that, you would then go back through the loop to modify your code, redeploy, and retest. So a familiar workflow, I would hope, there. As with all these things, the speed with which you can go around this loop is quite important. you, as a developer, your productivity increases if the speed you manage to do this loop is small. So anything you can do to keep that small is better. So that's why it's better to use tools that will help you automate this, so that you're not spending time and cognitive load doing parts of this that you're not really interested in. Because what you're really interested in is the writing the file, writing the code, and then seeing the result. So that's why it's a good idea to use some kind of environment to help you with this. Just to talk you through some of the commands for this. So compiling this, we can do this via, so we can use cargo for this, and the commands there. We're compiling to BPF, so we use that command to get our bytecode, and you run that from the directory that your cargo toml file is located in. So just in the normal Rust routine there, and that will produce files in your target directory. So it's this is where it's a little bit different to what you would normally get in Rust. So you get a binary as you would in Rust, which we have here with our core program name, which is the one that will be deployed. But we also, excuse me, generate a key pair file as well. So this is a Solana specific thing here, because we need this account to be associated with a program. And within the cargo config file, we can specify the program name there, so that will be how it will be named if we want to. And then to deploy the program, we use this command. So we're assuming you've got the command line tools there, so you can do Solana program deploy, and then you point that at the binary file that you got from compilation. And you will need obviously some LAN ports to be able to do this. And as I say, it's a good idea to have scripts to automate this as well, especially if you have multiple programs that you want to deploy. It's better to have some scripts to automate the whole process. It reduces the cognitive load, reduces the chance of you making typos, etc. Makes your life easier. All right, so that's what we need for getting to the getting our programs deployed, and then we will want to interact with it, and how we interact with it will depend on what type of client we have. And I'll come on to more about. We'll have some examples of interacting. I'll show you in the repo in a moment. So what we generally have stored in accounts is the if it's the program, then we're going to have the bytecode and hash. We obviously want to be able to verify this efficiently, and then the state will have an account for the state, and that will be whatever you decide that is going to be. So it could be anything. It could be number of votes that somebody has. It all depends what your program is trying to do. And as it says here, it is slightly confusing, the fact that we call so many things accounts. But anyway, that's the way it is in Solana. So you just need to kind of get used to that. But just remember that, yeah, the state that you're interacting with is going to be in an account, and that you supply that to the program that you're calling. Okay, so I'm going to go through some practical instructions. in a moment, I'll show you some examples that I want you to go through. But in order to understand that, you'll kind of have to follow these instructions. So the prerequisites, which I think you already will have because you've been because of the previous lessons you've done, but obviously you need Rust installed and have the compiler or cargo manager ready to use. You will need some kind of client, and you need the command line tools available and installed, and then we will supply you with some the repo for some of the examples. There's the details here. If you don't have these things installed, you can do that. So the repo that we're going to use is this one here called Solana course. So you use this for the Rust homeworks, but now we've added some extra directories specifically for writing the programs. And you can run this in Gitpod if you prefer, if you don't want to clone it locally. If you, I would advise you set up something like VS Code, and a nice way of doing this is is shown here. So you can set up your VS Code to have one of the windows as your editor as usual, and then one terminal window for your local cluster. So that's running your local cluster, and then another window with to show you the logs from that cluster. So this will help you see what's happening as you interact with the programs. Okay. There's screenshots here to show you how to do that in VS Code. So to create a terminal and split it. Or if you want to use tmux, if you're familiar with the Unix utility tmux, you can also use that, obviously. Now, the development environment that you want to work with, you can choose what this is going to be, but this the easiest way to do this is to set up initially anyway, is to set up your own test cluster, and so you can do this with that command, and it will come back with something that looks like this, gives you details of where it is running. The one you need to take note of in particular is this JSON RPC URL here. So you can see it's running on your local host, and the RPC port number is 8899. So you just need to take account of that. So when you're interacting with your local cluster, that is the server that you will be interacting with. That's the port that you will be interacting with. And then you can check which network your command line tools are going to interact with. We've run this command before, so you should be familiar with this. So this checks which network you're connected to effectively, and will bring you back something like this. So this would show you that you're connected to the DevNet on Solana. So if you want to change it, you can use the config set command and specify the URL. So to change it over to your local development environment, you can specify this URL here, and that will set you up interacting with the local cluster that you've created. And then you can check that by rerunning the config command there, and it should show you that you're connected to the local one. Okay, and then to help you understand what's happening, you can run the Solana logs command in another window, and this will then bring you back information from the cluster to show you what is happening as you interact and do deployments, etc. And the messages that you get in there come from the program using the MSG macro. So as we shall see when we look at some of the programs in a second. You can query your balance by Solana balance, and you can, if you don't have sufficient balance, you can give yourself an airdrop of some Sol. Now, if you're doing this, if you've got your local cluster, you can really do as much as you like, I think. But if you're on DevNet, it's the best amount to ask for. Apparently, is around 2 Sol. So you just run this Solana airdrop, and then the amount you want, and it will airdrop you that into your the account that you have configured from your command line. The 2 Sol should be enough to be getting on with. I mean, the amount you need to interact with your to deploy your code, etc., and interact is not that great. So that should be enough to run for a while. Okay, and then this is just an overview of the repo that we've provided that you can look at. So what we will be looking at this week, and maybe a little of next week, is the in the examples bare metal directory, and this typically each example we've provided has 2 parts, 2 directories. One holds the Rust code that you will need to deploy. You need to compile and deploy to the cluster, and then there's some TypeScript code in the client directory that you can run to interact with the deployed program that you have. Now, to make things easier, we've written a number of utility functions in this file, utils. This directory is called utils, and these are wrappers for functions that you will typically need, such as establishing connection or loading a key pair. So those are there. They are wrappers around the normal API calls as well. But you can have a look at those and see what those do as well. But they're there just to provide, just to make things a little easier for you. And then we also have written scripts to help you as well, as you can see. So you can run these with Node, and so rather than, so this is just to automate some of the workflow. So you can do npm run build, which will then will compile all of the programs for you. That actually, if you did it manually, would run that command that you've got there. So it's just to make it a little bit easier for you. And similarly, for deployment, we've got scripts for that. So you can use npm run deploy and then a number. And then once you've deployed your code, if you want to interact with it, you can do npm run call and, excuse me, a number, which will interact with that particular program. And the numbers here refer to the number of the example that we have done. So you'll see the examples are numbered, so you just need to provide that. And then yeah, the clients, they sort of go through these steps, learning everything, the libraries, the binaries, the key pairs that we need, who is going to the key pair for who is paying for everything. They set up a connection to the cluster, and then create, they serialize the arguments that we need to provide to the function, and build that into a representation, and then call the program, passing that as an RPC call. And then we then can do another read after that transaction has been sent to see the modified state that has happened. And it also gives logs a cost of interaction as well. and there are some additional checks we've put in as well, just to make sure you have enough sol, etc. Yeah. So that's the overall process. So if you're following the examples, I'll show you the examples in a second. This is what you need to do just to run those scripts. So you can do npm run build, run deploy :1 to deploy example 1, and npm run call :1 to interact with the example 1. The first example is very simple, as I'll show you in a second. And then for the second example, it's the same thing, but just replacing the 1 with a 2. There are some links there to give you more details about accounts and some examples from the Solana cookbook and the Solana wiki if you want to have a look at those. But now I'll go on to looking at these particular examples. So this is the repo. So example 1, as I said, we have client and Rust.
Lawrence, that's a quick start. So we'll go to Solana course.
Sorry. Yeah, thank you. Yeah, okay. Sorry.
If you can refresh it.
Okay. Yeah. So this is the Rust code for our Hello World example. So very simple program. This is really to show you that everything is to take you through the deployment process, and just to make sure that that is all, you understand that is all working fine. So at the top of this here, we have the things we need to bring in from the Solana libraries. We're specifying here the entry point. So we're saying the entry point here is process instruction, which we've got here. And then, as I showed you earlier, we're passing in the 3 pieces of information that we need to pass in when we're making our call, which is the program ID, the accounts that we need to provide for the state that this program is going to use, and then the actual data that we're going to run. Now, in this case, we don't really have anything we're going to run, because we're just going to use the MSG macro to output a message to our terminal. So we're not really going to pass in any instruction data in this particular case. And then we give a return. We need a return of type program result, so we return OK from that. Okay, so that's the Rust code. The client code, you'll see here again, we're importing some things from the Web3 libraries, and also then from the utils file that we've provided. We've set up some paths here, and the paths to the key pair that we're using, so that allows us to get who is paying for this particular transaction. Then we can create a connection to our cluster. We can check we've got enough sol. We can do we can check the balance there. We check the program has been deployed okay, and then we can call the code itself, or say hello, which is down here, which we're passing in the things we need to put across to the program, and this then creates the instruction, the transaction that we need to put together. In this case, we don't have any instruction data because we're not actually running the instruction data in the code. We're just putting a message to the message macro. And then once we've done that, after the say hello, we come back and get the balance and get a log of the cost of this, and then log this to the console. So that's what the client looks like. If I go back to the here, you can see the utils. So this is the utils code here, where we have these particular functions that are written that are wrappers for the typical Solana calls. So these are just to give you a little bit of extra functionality. So that's those. That was example 1. Example 2, the counter is here. So this is a little more in depth, because we are now going to use some state. And so for this, we need to have some serialization scheme. So we're using Borsch serialization for this. And what we have at the top here, lines 13 to 15, is a struct to define the state that we have in our account. So we're saying to the program what the bytes that are in the account, what do these actually represent when they are deserialized. And so we're saying it's going to be a counter, an unsigned integer counter. Again, we specify our entry point, and then here we're passing in the details as before. We output a message to show that we've started processing this particular example. And then we start to go through the accounts that we've passed in. And we iterate through those, and we're messaging details about that. We need to make sure that we have the correct accounts there, and with the correct one has the program ID that we want. And then once we have that, we then take from the account, the account that has our state, we take from that the particular piece that we want. So we're doing this, we deserialize it by this try from slice, and that gets deserialized into our structure that we want. So we've gathered into our greeting struct. And once we have that as a Rust variable, we can then interact with that, so we can add one to our counter there. We then message, put an output to the console to say that we've done this, and then because we've changed this, we then serialize it back into the account. These, the serialization is. It looks a bit odd, but you just have to kind of get used to the structure of that. And then once that's written back into the account, we can message to the output that we've done this, and then return our program result to say that's all been done. Okay. Right. So those are the 2 examples I would like you to look at today. So you need to go through those. And deploy those examples, and then run. So you can use the scripts that we've supplied to deploy them and call them from the client. But I think it's best if you go through and make sure you understand at all the steps that you're going through, what is actually happening. So by all means, sort of just run through it first of all to make sure that your environment and everything is set up okay. But then I would go through it, look at it in more detail to make sure that you understand what is happening within the program and what is happening within the client at each step. And if you want to put in extra messages, output extra messages to show this, I think that's a very useful way of doing that. So you could put in extra messages to output into your window to show what is happening at each stage as well. Obviously, when you do that, you'll need to recompile and redeploy your code to do that. Okay. So that's what we want to do for the practical part of the lesson. So in the next half hour, and then for the homework to do, we have some questions to discuss in your team. So questions about the sort of architecture we've been discussing, and the way we deploy things, and the way that we write our code, and then some tasks as well to expand upon the examples that you've gone through, and we've got a hint there to help you with that. So as always, please work through this at your own pace. If you want to work through these in your teams, that's always good. Or if you want to work through with a partner, that's a good thing to do. I think that will help you. And if you have questions, please put them into Slido, and then we can give you some sort of quite detailed answers to those. And I'm going to stop talking now because I think I'm about to lose my voice. All right. So yeah. Please do ask questions if you have them, and I'll let you get on with that. Thank you, everyone. Oh, something. Yeah, you need to, before you do the npm part, you need to run npm space I to make sure that it installs all the relevant packages. So yeah, so when you're in those particular directories, run npm I, and that will make sure you've got all your npm packages installed.
Just a small correction. This is in the root file that you just need to run npm I, and that's it. Quick note: if you would like to validate on which network you're connected, you can run Solana Solana config get, and that will list are you connected to localhost or a devnet. Solana config get.
I've updated the file in the Discord README to fix a typo, so please take the latest one there, the lesson12.pdf. Thank you.
Hey guys, just one clarification when it comes to the logs. You basically need 3 terminal window, okay? 1 terminal window for running the validator, so that's just running it. Second window that have to be separate to run the Solana logs, and the third window to run actually the npm commands. So you need to make sure that your test validator is on when you run Solana logs, because they will connect to it, and then the client calls will also connect. And you don't kind of need to look at the cluster logs, you just need to see at the Solana logs. So yeah.
What do we do if our validator command is not is panicking? Any guidance on that?
So the panic was the error message?
I'll put it in the chat. It's showing thread main panicked at called result unwrap, uncategorized, some kind of privilege. Okay. Yeah.
So actually I think for both your Oliver and Yusuf problems, are you sure you have a Solana CLI installed?
Yep.
Try to run in an administration mode. If you're on Windows, yeah.
Correct.
Yeah, I had the same. I mean, I ran as an admin in VS Code, and it worked for me.
Okay. Sounds good. I'll try that. Thank you.
Yeah. You're welcome.
And then Yusuf, maybe try running in the bash. I'm not sure on what OS you are as well, but maybe your path to Solana Mac. Okay, so the and it's it's not Solana dash logs, it's Solana space logs.
Hey, I don't understand the program size. You mean the account size for random exception or the program itself?
That is that is in the examples homework.
Yes, the second task says retrieve the total program size of example 1 hello world. We need to print that somewhere, right? Or just see some information when we deploy the program.
Sorry, Vincent cannot get his mic working. I think that's basically the that's just the cost of the account. I haven't seen the question. Sorry.
Yeah, I think it's just getting some details about the size. Yeah, of the deployed the pipe code. Yeah.
Okay. I think you can see that on from Solana account, and then you can specify which account.
Yeah.
Let me just validate that. I closed my cluster.
The total program size or the file, you mean the shared object?
So basically you can, so what I think is Vincent is asking is what is the size, what would be a fee for the rent? And fee for the rent is based on the size of the program. Let me see if I can see it.
Okay, so it's the fee, the amount of LAN ports you have to send for fee for rent exemption, right? The thing that you're calculating in the main.ts file, right?
Yeah, there is an answer on the slider for that, I think. So yeah, so the size of the binary, from that size you can work out the amount of LAN ports.
Let me send you my answer in the direct chat if I want to check if I'm wrong.
If you put it in, oh, okay.
Yeah, I mean you can exactly put it in Discord, and it will basically answer you.
Yeah.
You there. Oh yeah, greetings.
Okay, so we'll answer that on Discord. Then I think that's the best place for it. And otherwise, we're out of time now, so we'll finish here. Thank you everyone for taking part. I hope you found that useful. If you have questions, please you can still put them on Slido or put them in Discord. Either is fine, and we'll answer those. Otherwise, we'll carry on with this and with further examples tomorrow. So we'll see you then. Thank you, everyone.